Alright, this is Chapter 8, Section 6, Solving Rational Equations. Our learning objective is to solve rational equations and to use rational equations to solve problems. It's essential that we understand that to solve an equation with a rational expression, I'm going to highlight, this is what I do. I want to first multiply each side by the least common denominator. And then once you do this, be aware of the extraneous solutions, which means check your answers. You may get some that don't work. Alright, so let's take that method and apply it to this situation. We're going to find out what are the solutions of the rational equation x over x minus 3 plus x over x plus 3 equal to 2 over x squared minus 9. So our goal is to find the least common denominator, so we are going to factor out everything. Thankfully, these guys are already factored. It's the one on the right-hand side that's not, and this is a difference of squares. So a difference of squares breaks down into minus 3 and plus 3. So the least common denominator between x minus 3, x plus 3, and x minus 3 times x plus 3 is the product of x minus 3, x plus 3. So what I'm going to do is I'm going to multiply both sides by x minus 3 times x plus 3. I'm going to do it to this side as well. So you do it to the right, you have to do it to the left. So let me show you how that works. So I've got x minus 3, x plus 3, and it's going to be multiplied here and multiplied here. It's like distribution. When I multiply it on this side, I'm left with just 2. Now I'm going to simplify it here. When I multiply it here on our first term, the x minus 3 and the x minus 3 cancel, and I end up with x squared plus 3x, a plus sign. X plus 3 cancel. I'm left with x squared minus 3x. Oh, now we have something awesome. We can solve this. This is easy. X squared and x squared give me 2x squared. 3x minus 3x is 0, and that's equal to 2. Divide both sides by 2. And you get x squared is equal to 1. If I take the square root of both sides, I need to make sure that I include the plus and the minus. So the possible answers are x can be either positive 1 or negative 1. So this is where extraneously we got to look at if the answer works or not. So we need to do a little check. So we're going to check x equals 1. So everywhere there's an x, we're going to put 1. So it's 1 over 1 minus 3 plus 1 over 1 plus 3 equals 2 over 1 squared minus 9. Negative 1/2 plus 1/4. This is 2 over 4. Negative 1/4 equals negative 1/4. So x equals 1 checks out. Now we're going to check x equals negative 1. So I'm going to put it in my equation. So I get negative 1 over negative 1 minus 3, which is negative 4. I get negative 1 over negative 1 plus 3, which is negative 2. And I get 2 over negative 1 squared, which is 1, minus 9 is negative 8. If you look here, I got a negative on the top, a negative on the bottom. That's positive 1/4. Here I have a negative on the top, a negative on the bottom. That's positive 1/2. Is there any way that a positive 1/2 plus a positive 1/4 can equal a negative 1/4? Answer to that is no. No way that can be possible. So we have an extraneous solution. X equals 1 is our only solution. On the quiz for this section, you will have extraneous solutions. If you do not check your solutions, you will get one extra solution. So make sure to always check. Alright, so we're going to find the solutions of the rational equation x minus 1 over x plus 2 equals x squared plus 2x minus 3 over x plus 2. So the first thing I want to do is multiply by the common denominator, and thankfully it's already common. So I'm going to multiply both sides by x plus 2. When I do that, my denominators drop out and I am left with just my numerators. And then I have to replace each other. In this case, I'm going to get all the x's on one side of my equation. So I'm going to factor this guy out because I'm amazing at factoring. Thank you, Algebra 1. Two numbers that multiply to give you negative 2 and add to give you positive 1 are positive 2 and negative 1. So this equation is true when x plus 2 is equal to 0. And this equation is true when x minus 1 is equal to 0. So my answers are x equals negative 2 and x is equal to 1. But I need to plug them back in to my original equation to make sure there's no extraneous solution. And I already see a terrible, terrible solution. Which one of these for sure, looking at our original equation, which one of these for sure will not work when we plug it back in? Yeah, the negative 2 makes the denominator 0, so I know for sure not negative 2. But let's put 1 in just to be sure. So I have 1 minus 1 over 1 plus 2. I have 1 squared plus 2 times 1 minus 3 over 1 plus 2. Simplify, this is 0. 0 divided by anything is still 0. 1 plus 2 is 3. 3 minus 3 is 0. Is 0 equal to 0? Yes, it is. So x equals 1 is our solution. Alright, so let's do two rational expression word problems, because it seems that kids in America have a hard time with word problems. They just get discouraged that math is written in English language instead of math language. So let's take a look at these two problems. You ride your bike to a store 4 miles away to pick up things for dinner. When there is no wind, you ride at 10 miles per hour. Today, your trip to the store and back took 1 hour. What was the speed of the wind today? We're going to remember the little fact that distance equals rate times time. So when we're looking at a distance of our distance to the store and away from the store is going to be 4 miles. And our rate times time is, we're going to factor it in. So let's take a look at what we know. We want to make sure that x is equal to what the wind is doing. So x is equal to the wind speed. Our speed is 10 miles an hour. E's constant. So our rate is 10 miles an hour. And what we're going to do is we're going to remember that our total time is equal to our time there time to get there plus time to get back. And in Algebra 1, we work on manipulating equations. So if because I want things in terms of time, I'm going to take my d equals RT, and I'm going to solve for t. And I know t equals my distance divided by my rate. So we're going to start replacing with what we know. Our total time is 1 hour. The time to get there is a fraction of that 1 hour. So our time to get there, we rode 4 miles. And normally we ride 10 miles an hour. But on the way there, we had some wind. So it gave us a little oomph in our speed. So that's the way there. On the way back, still 4 miles. But the wind was not our friend, and we were riding against the wind. So now we have a cute little rational equation. So we're going to follow the same steps as here, where we find, so we're going to factor the denominator, we're going to factor the, they're not factor, we're going to multiply each side by the LCD and then simplify and solve. So least common denominator here is this 10 plus x and the 10 minus x. So everybody's going to get multiplied. So when that happens, 1 times 10 plus x, 10 minus x is 4 over 10 plus x times 10 plus x, 10 minus x. The 10 plus x's cancel and you get 4 times 10 minus x. 4 over 10 minus x times 10 plus x, 10 minus x. The 10 minus x cancels and we get 4 times 10 plus x. Alright, so we're going to simplify, combine like terms, solve. Everything we know is the right thing to do for these problems. So the first thing I'm going to do is distribute 10 times 10 is 100, and I'm going to actually move it. Let's move everything down. I need more room. 10 times 10 is 100. 10 times x is 10x. Negative x times 10 is negative 10x. Negative x times positive x is negative x squared. These cancel. I get 100 minus x squared. 4 times 10 is 40. 4 times negative x, negative 4x. 40 minus 4 plus 4x. There we go. 4x negative plus 4x is 0, and 40 plus 40 is 80. Let us subtract by 100. Negative x squared equals negative 20. So therefore, positive x squared has got to be equal to 20. How do we solve it once we get to here? X squared equals 20. How do we get rid of a square? That's right. Square root. Booyah. So if I take the square root of both sides, I'm left with plus or minus square root of 20. And let's get the approximate value. So the square root of 20 is 4.5. So this is approximately equal to 4.5 plus or minus. And that would be miles per hour. All right, so we have to test for extremes. 4.5 positive and then negative 4.5. Is it possible to ride negative 4.5 miles per hour? No. No. So we know it's not the negative part, but just the positive. So the answer is positive 4.5 miles per hour. All right, it happens. Classic train problem. It's the one that your parents are warning you about. A passenger train travels 392 miles in the same time it takes a freight train to travel 322 miles. The passenger train travels 20 miles an hour faster than the freight train. Find the speed of each train. So what I like to do when it gives you a bunch of speeds, a bunch of distances, a bunch of trains, I like to break it down into a table. You can't see this on the recording, but I am now breaking it down. Yeah, it's hilarious. You're missing it. All right. So we're going to make a table. We're going to have a train. Let's go passenger train. We'll call it the pass train. And then the freight train, we'll call it the freight train. It's going to have a distance, and it's going to have a rate and a time. All right, passenger train travels 392 miles. The same time it takes that freight train. C and T, same time, time's the same, to travel 322. The passenger train travels 20 miles an hour faster than the freight train. So we'll say freight train is R. The passenger train will be 20 plus R. Yay. Find the speed of each train. All right, so you guys know, let's put it together. D equals rate times time. So we got 392 equals rate 20 plus R times time. And the freight train is 322 equals rate times time. We do know that the t's are equal. So if I had this in terms of t, then I can set the two equal to each other and find my r. So t is equal to 392 divided by 20 plus r. And then this t is equal to 322 divided by r. So now here's what I know. I know that my times are the same, so I can say 392 over 20 plus r is equal to 322 over r. So I'm going to multiply both sides by r times 20 plus r. Boom. When I do that, I get 392r is equal to 322, 20 plus r. This would be 640. I'm going to subtract 322 from both sides. 322r from both sides. And 392r minus 322r gives us 70r. And lastly but not least, the other divided by 70. So 6440 divided by 70 is another 2. And rate is miles per hour. And let's go back and see what R is. R is the freight train rate. So we got this is 92. And let's see what they want. Find the speed of each train. So if the freight train is going 92, how fast is Mr. Passenger Train going? He is going 20 plus 92, which is 112 miles per hour. Mile per hour.